Hi everybody, we continue with this hiding partitions in the data hiding techniques. So the disk is partitioned and the data is hidden. So that is the technology. For example, in the following code, disk manager recognizes the extended partition labeled as extension DOS as being 5381 5381.1 MB. 1 MB. The log labels for partitions E through F indicate that they are logical partitions that make up the extended partitions. The log DOS labels for partitions E through F indicate that they are logical partitions. E through F, there are logical partitions. 5381 dot as being 5381.1 MB listed as megabytes. The log DOS labels partition A to F indicate that they are logical partitions that make up extended partitions. However, if we add the sizes of the drives, E and H is only 5271.3 MB, which is your first clue to examine the disk more closely. The remaining 109.8 MB could be a previously deleted partition or a hidden partition. For this example, the following code shows letter H to indicate a hidden partition. Right. So look into this. So here the disk 2 is divided. In figure 1, you can see a hidden partition, disk manager. This is hidden partition, disk manager, which shows it as an unknown partition. In addition, the disk drive letters and the visible partitions are non-consecutive, which can be another clue that a hidden partition exists. Most skilled users would make sure this anomaly that doesn't occur, however. Right. So this is the hidden partition. So next, in a ProDiscover tool, a hidden partition appears as the highest available drive letter set in the BIOS. So look into this figure 1.2, being a hidden partition in the ProDiscover software tool. Okay. Figure 1.2 shows 4 partitions similar to figure 1.1, except the hidden partition shows as a drive letter Z. Okay. If it's not visible here, drive letter Z to carve or salvage data from the recovered partition gap can use other computer forensic tools such as FTK or WinHex. Marking bad clusters common with FAT systems. So this is another technology that's all about hidden partitions. Next is marking with the bad clusters common with the FAT systems. Please, this is common for FAT systems. Place sensitive information on key space. Use a disk editor to mark space as a bad cluster, to mark a good cluster as a bad using Norton disk edit type B the FAT entry corresponding to that cluster. Bit shifting. What is it? Bit shifting. This is an olden technique. Shift the bit patterns to alter byte values of data. Shift the bit patterns to alter byte values of data. Okay, so the pattern of the bits is to be shifted to alter the byte values of data. Make files look like binary executable code. So tool is a hex workshop. By bit shifting changes the data from a readable code to data that look like binary executable code. Hex workshop includes a feature for shifting bits and altering byte patterns of entire files or specified data. To shift bytes in a text file, follow these steps. Okay, right. So it is shown as an example. Look into this. D shifts to shift the byte data. The last one is steganography to hide data. So the hidden writing, we call it as steganography. By inserting digital watermarks into a file, we can hide a portion of our data. So to notify our user that an image is copyrighted, the digital watermarks used for steganography aren't usually visible. However, when you view the file in its usual application, and might even be difficult to find with a disk editor. A non-steganographic graphics file is same size as an identical steganographic graphics file, and they look the same when you examine them in a graphics frame utility such as Irfan View. However, if you run an MD5 or a SHA1 hash comparison, both files, you will find that the hash values aren't equal. Okay, thanks for watching. Thank you. We'll discuss upon the remaining topics in the next class. Thank you.